Hi guys, I have a couple of questions from section 4.3, 87 and 89. We may be able to get them both in the same video here. So the question is the one that they want us to take the logarithmic expressions and reduce them to a single log with a coefficient of 1, which means at the end you want only one log term and also with a number 1 in front. So here's our problem in 87, says log. I hope I can fit everything here. It is kind of long, and I'm pretty sure the person who asked about it is probably the reduction part, because it is going to involve reducing some fractions. Maybe that's what gave him a little hard time. But we'll work it through here. But as far as the log is concerned, it's not going to be really that bad. It's just that dealing with the reduction. Anyway, let me write the problem. So we have 1/3 log base b of x to the 4 y to the 5th minus 3/4 log base b of x squared y. Okay, so here's our problem. They want us to condense this to one log, single log, and also the number in front should be 1. So the first thing you're going to do, remember those three properties, the product property, power property, and the quotient property, which I'm sure I've reviewed them in the previous videos. You might want to review them again. So first thing we're going to do, we're going to remove the numbers in front. And every time you want to condense 2 or 3 more logs into one log, if there are numbers except 1 in front, you need to remove it. And of course, that's what the power property helps us. It takes this number, we're going to take this coefficient, make it a power or the exponent of our expression here. Okay, so it'll become log base b of x to the 4, y to the 5th, and then the whole thing raised to 1/3. Okay, and then similarly, same thing, we're going to take 3/4, make that a power by the power properties. So that becomes log base b of x squared times y raised to the 3/4. So now we have a difference. So of course, as you know, the way you go from difference of 2 log to a single log is by the quotient property. So this becomes log base b of the top. If you don't mind, I'm going to go ahead and actually, anytime you have 2 powers, as you know, on top of each other, you multiply. I'm going to go ahead and multiply that so we can save a step. So 4 times 1/3 becomes x to the 4/3. 5 times 1/3 become 5/3, y to the 5/3. And then over, because remember, difference always becomes a quotient, over log base b of, and here again the same thing, I'm going to multiply the exponent, 2 times 3/4. And by the way, 2 and 4 do have a common factor of 2. So as you reduce 4 by 2, that becomes 2, and that 2 becomes 1. So that just becomes x to the 3/2. And then finally, y raised to, therefore there is no power except 1, so I'll just be y to the 3/4. Let me just pause here for a minute, because basically so far we have definitely, oh, I do apologize. Sorry guys, there is no log down here. It's just log of the quotient, not log over log. Sorry about that. So you just have one log. So it's log base b of this quotient. So what we did, we went from difference of 2 log to a single log by, of course, using a quotient property. And I'm pretty sure the student who asked about it, maybe the problem was because the answer, you cannot leave it like that because you have some common factors. You have factor x, factor y, 2 different powers. So you do have to reduce this expression, okay? So I'm going to go ahead and that's it. So once you reduce that, then that will be your final answer. I'm going to see if I can maybe take those 2 steps off and see if I can show you how to reduce this right here. So of course, as you know, anytime you divide 2 things with the same base, you write one of the bases, and in this case x, and you subtract the exponents. Same thing with the y. So we're just going to write x, and then 4/3 minus 3/2 times y raised to 5/3 minus 3/4, right? So you always, when you divide, you always subtract the exponents with the same base. So I'm going to go ahead and start that here. So this is, of course, so we still have the log, but I'm just going to work that out a little bit. So we still have log base. So now I'm going to go ahead and write 1x, except we're going to subtract the power. So that's 4/3 minus 3/2. And then, of course, times y. Again, subtracting the exponent, that will be 5/3 minus 3/4. And the next step is to combine the fraction to a single fraction. So, of course, between 3 and 2, LCD is 6. So we're going to, of course, make 3 6 by multiplying top and the bottom by 2. And we're going to make 2 6 by multiplying top and the bottom by 3. So that will give you the same denominator. So you can just combine the tops. Same thing here between 3 and 4. LCD is 12, so we're going to multiply 3 by 4 to make it 12. Again, top and the bottom. And also, to make 4 12, we're going to multiply top and the bottom by 3. So at the end of the day, this becomes log base B of. So this becomes 8, 2 times 4 minus 9, which just reduces to negative 1, 6. Because remember, the denominator is 6. It's common, and that's why we are able to combine them. And the top 2 times 4 becomes 8, minus 3 times 9, which is 9. And 8 minus 9 become negative 1. And the same thing here. 4 times 5 is 20. 3 times 3 is 9. So 20 minus 9 becomes 11 over the same denominator, which of course is 12. And that's it. Now, sometimes they do remove the negative exponent, but I think in this book they actually do leave the answer with a negative exponent. So there is your single log with a coefficient of 1. Okay? So let me see if I can, the other one is pretty short, so let me see if I can do also number 89. Okay? But this is number 87. So number 89 is much quicker, even though it may look kind of long, but so we have same question. We want to take this expression, reduce it to a single log with a coefficient of 1. So we have 2 log base A of z plus 1 plus log base A of 2z plus 2. 2z plus 2. So there's our problem. So here, first thing again, we always want to remove the numbers in front of the log if you're going to try to condense them to a single log. So that again, by power rule, that becomes, by power property, that becomes your power. So that becomes log base A of z plus 1 squared. Now this one that has no number except 1, so that will just remain the same. And then of course the last step would be to combine from sum of 2 log to 1 log, and that's the one we call product property. Sum of 2 log can be written as a log of their products, right? So this is just become log base A of z plus 1 squared times 2z. Sorry, this is supposed to be 3z. Sorry about that. 3z plus 2. 3z plus 2. And actually, that's it. That's the way you can leave your final answer. So there's your, I'm just going to put a bracket around it. There's your single log with a coefficient of 1. Okay, and that's the way. They don't want you to expand it. Just going to leave the answer like that. Okay, so the final answer would be log base A of z plus 1 squared times 3z plus 2. I hope that helps.